sheer academic interest. We did it because we had a specific intention, and that is to process these materials. And this is an example of the culmination of some of our work. This is an ash beneficiation plant that we built. It's a mobile facility, and it's sitting on the shores of the active pond in Carroll County, Kentucky, at the Gent Power Station. There's about 7 million tons of ash in that pond behind me there. And what we were doing was we excavated it and ran it through this process to generate up to 5 different marketable products that could be beneficially used for sustainable construction materials. And some of this technology has been adapted. These are 4 commercial operating plants right now. The 2 in North Carolina produce lightweight aggregate from bottom ash, so rather than quarrying stone or using natural lightweight aggregates, which have to be processed in intense heat, we recover the bottom ash, remove impurities, and use them to make lightweight concrete blocks, and they each produce around 80,000 tons per year of a marketable product. The one in the middle of Avenue, Missouri, actually takes the standard weight bottom ash and fly ash together to prepackaged concrete. So if you go to the Home Depot anywhere in St. Louis, Missouri, you can buy a bag of Quikrete to do something with in your yard. It would contain bottom ash and fly ash rather than the traditional construction aggregate. And the one over on the far right is a gasification facility in Mulberry, Florida, outside of Tampa Electric's facility. When we began working there, they had absolutely no way to use any of their byproduct materials, and we're generating around 80,000 tons per year. So with a very simple process that we installed there and eventually patented, they have no byproducts now. They utilize 100% of what they produce. So that was a very successful project. Of late, I've been solicited to help with the CO2 capture program that we're working at the University of Kentucky. We have a greenhouse, and the students are here. They work very hard at dealing with these algae tubes. This is what the facility looks like on the inside. We're trying to understand the growth cycle of this. I'm not used to working with living organisms. Most of what I work with is usually dead. But this has been a real challenge, trying to keep this stuff alive. But the whole purpose of the program is to demonstrate if using algae would be a viable alternative for capturing CO2. We have the sequestration technology. That's not the problem. The problem is how do you capture, how do you selectively recover CO2 from a high volume flue gas effluent. So this is one of the approaches that we're looking at. We have done it in the laboratory with a variety of different organisms. And currently we are in the middle of construction at a power plant, Dale Power Station in Fort Kentucky, on the Kentucky River, down near the Falls on the River. If you ever get down that way, look on the railroad tracks. What you will see is a construction of a facility here. There's a power plant in the background. We build all this in our lab here in Lexington, take it apart, transport it, and assemble it in the field. So the tubes have been installed. That's what it looks like right now. We want to be starting it up as soon as possible, as soon as we get all of our equipment in, and hopefully one day, if everything works the way we would like it to, our hope is that it will look something like this. So, in a nutshell, my career, how does energy affect my career? Well, I've worked with coal all the way from the mines all the way to the end of the power plant stack and kind of running out of processes.
Thank you, Dr. Bravo. Our last panel speaker is Dr. Stacy Clausen. He's a visiting distinguished lecturer at the Patterson School
over all of our energy use. So we import 60% of our oil, right? And on the right, what you see here is that we are dependent on oil-producing states, primarily the Americas and the Persian Gulf, right? So that kind of looks like a somewhat happy picture, right? Canada's our friend. The problem is on the left, our dependence on Persian Gulf will continue based on estimations of where the world's proven oil reserves remain. Proven oil reserves, right? What you can get out of the ground now at an affordable price with the technology you have. Okay? So let's test our energy IQ, right? So let me just get a show of hands. How much more energy is the U.S. going to need in the next 20 years? 0 to 5? 10? No? 6 to 10? You? 11 to 15? Okay, 16 to 21. Okay, so you're all on the higher end. Actually, it's just 6 to 10 so far. About what percent of global energy demand in 2030 will be met by fossil fuels? Oil, gas, coal, right? So 25? 45, 65, 85. Okay. The pessimists win at 85. The optimists 65, right? If we do get those alternative fuels that we need. Let me just give you an example. Even if huge increased alternative sources come from fossil fuels, we'll still need 60% of fossil fuels to meet our demand in 2030. Okay, so finally, what percent of the world's proven oil reserves do the U.S. companies control? Right, U.S. companies, 0 to 10. Okay, 10 to 20, 20 to 30, 30 to 40. I am very sad to say 0 to 10. Okay. So ExxonMobil, for example, the largest U.S. oil and natural gas company, does not even rank among the top 15 oil reserve holders in the world. Okay. So we're kind of in trouble. Right? We're 4%, or now I've heard 3% of the world's population, and consume a quarter of its oil. Right? We're only surpassed by China in consumption of oil, but we still consume more oil per capita, per person. Okay? And we pay a lot. It's half of our trade deficit per year. Half of our trade deficit is for oil, $630 billion. The government is the largest purchaser. It's more than we have in debt to China. Okay? So these guys sell us our oil, right? And much of the world comes from countries, much of the oil comes from countries that we don't necessarily get along with, right? We think they violate human rights, we don't agree with their approach to solving critical global issues. For every $5 a barrel of oil goes up, Ahmadinejad gets $7.9 billion. Okay? So oil is left behind now that we have to get. It's hard to get to and it requires advanced technologies. Now, our private U.S. companies like ExxonMobil have this technology, but it's difficult investing in countries like Hugo Chavez's Venezuela, where he has recently renationalized the oil companies and won't allow us to cooperate with them anymore. So to ensure the supply, we have to have a national security. What are we going to do? National security strategy? What are we going to do about oil? What we do, the White House puts out a national security strategy. It's very broad. We need to ensure our security and free flow of global energy resources, and we need to diversify our supplies, investing in innovation and deploying clean technology. Right? That's a big deal. So security and free flow of global energy resources is threatened. It's threatened every day. Right? Just in the last year, right, we have civil unrest in Nigeria, we have Iranian nuclear missions, which mean we have to sanction Iranian gas field production, there's oil spills off the shores of America, China and India's robust demand growth, Russia cutting off supplies to Europe. So how is diplomacy, right? I'm from the Patterson School of Diplomacy. So what do diplomats do? Well, when the U.S. ambassador gets assigned to a post, right, so he's going to go to Moscow, he gets a letter from the United States, and it basically says, you, the ambassador, the chief representative of the United States, and this means that you're representing all government agencies. So you're the chief of all government agencies in Moscow. So at the moment, there are 4 priority areas identified by the Department of State for U.S. ambassadors, right? And energy is becoming increasingly part of ambassadorial portfolios, right? Because they're at the front of the sphere. So the first thing is diplomats work on enhancing energy efficiency. We've heard about energy efficiency. We're kind of taking this message abroad. We're trying to convince the world that energy efficiency is critical. Why? Because it frees up more supply, right? So reducing demand for fuel through efficiency reduces the amount of energy that we need. So we work with many countries on this. Then we've got this global shale gas initiative. We're also trying to replace oil with other things. We don't want countries to use so much oil and coal and dung and wood. We want them to use gas instead. So we have ambassadors that are working with 20 countries on this. And in China and India, what we're trying to do is develop gas in an economy-size scale. It's only about 3% of the Chinese portfolio at the moment. Efficiency can also be about getting more reliable supply, right? We've got about 1.5 billion people in the world who don't have electricity. So we're talking about trying to connect them. And if they're newly connected, we're trying to create renewable energy for those grids. Places like Haiti, India. Okay, the second thing diplomats do is they work to protect our markets, because we need open markets. We need this oil economy, right? So conflict prevention is a big part of securing markets. And there are more obvious issues of concern, like a terrorist attack on the Saudi oil facility, right? That would do huge damage to the markets, right? But there are less obvious concerns, like we're really concerned about, let's say, civil war in Indonesia. Why? Right? Because in civil war in Indonesia, blocked the Strait of Malacca, right, between Indonesia, Malaysia, and Singapore, and the next thing you know, a quarter of the world's oil traffic is blocked, right? So there's also the work done by ambassadors to avoid war between oil-producing states. I mean, the classic is when Saddam Hussein invaded Kuwait, right? We didn't want to push the Gulf to stabilize, but the more recent example is when the Venezuelans and Colombians had they're two oil-producing states, right? So we went to work on that. And third, diplomats work to diversify our energy supply by basically finding new suppliers. Right? One of the new suppliers are in Africa and Latin America, right? So the ambassador is the leading trade promoter for the U.S. in the country. He's like basically, you know, the person who's trying to get U.S. companies involved in other countries. So, for example, in Mozambique and Equatorial and Ghana, right now, Equatorial Guinea and Ghana, what the ambassador is trying to do is bring in American oil service companies and help them produce oil and gas. This also involves American companies constructing pipelines, right? So ambassadors often negotiate on pipeline deals for U.S. companies that cross multiple states. For example, from Baku, Azerbaijan to Ceyhan, Turkey, for example. So finally, diplomats expand the collective energy system. What does that mean? Basically, they work with multilateral institutions, and this ties back to nuclear. I mean, as the know-how.
The rolling boulder crashing down the mountain. That's kinetic energy. Kinetic. The boulder sitting high up on the mountain. That's potential energy. Potential. Energy in motion is kinetic. Energy that's waiting